So this week we're going to talk about the unit circle, and this is from section 5.1. So to talk about the unit circle, we first have to talk about the special right triangles because that is where the values on the unit circle come from. So you'll notice I have fixed the hypotenuse in these two triangles that I drew as having a value of 1. And so the unit circle has a radius of 1, so the hypotenuse is always going to be 1. So that's why I fixed that. And these values, root 3 over 2, 1/2 for the 30, 60, 90, and root 2 over 2, root 2 over 2 for the 45, 45, 90. Those are the values that just repeat on the unit circle. So I'm going to go up here to this picture. So I drew a circle, and the equation of this circle is x squared plus y squared equals 1. So that is the equation of the unit circle. It's a circle centered at 0, 0 with a radius of 1. Normally when this is introduced, it's not introduced on an XY axis. I like to do this so that you can see that each of the points on the circle is just a coordinate point on an XY axis. So the first one I drew, so I drew this, this line right here. That is going to represent the angle. Let me put a little line here. Of 45 degrees. Okay, so the angle between the x-axis and that line is 45 degrees. Now, if I just drop a line from that point on the outside of the circle, let's count how many squares over it is, for instance. So the whole circle has a radius of 1, and I am 1, 2, 3, 4, 5, 6, 7. 7 units, of 1. So basically I'm at 0.7. So the coordinate here, if I were just to do a quick approximation, would be 0.7 and then 0.7. Okay, so it's over to the right, 0.7 up 0.7. So that's just a coordinate point. Now, since we know the angle here and we know the radius, so the radius of this is 1. The angle's 45. So if I just start filling this in, so that angle is also 45. And, what values did I have from the special right triangles for a 45, 45, 90 with a with a hypotenuse of 1? And if you look down here, I had root 2 over 2 as the value. And so why did I say it's 0.7, 0.7? Well, that was an estimate. So the actual value is root 2 over 2. And if you just put that in a calculator, it actually comes out to 0.707. So my estimate was pretty accurate because I'm just counting the squares over, the units over. So this coordinate point has a value of root 2 over 2, comma root 2 over 2. So this is an exact value, whereas the 0.7 was an approximate value. So that is just a coordinate point. So that is one example of where these angles come from. Now I could draw, any number of angles on here. I could draw the 30, 60, 90 and get coordinate points from that. Okay, so next I sketched out the line for a 30, 60, 90 triangle. So every angle that we're measuring is from the x-axis. So from the axis, if I draw this is the angle 60 degrees. And if I drop a vertical line from where that radius, hits the outside of the circle, then I create a 90-degree angle there, and so this angle is 30 degrees. Okay, the hypotenuse is always 1 because that's the radius of the circle. And let's just look at the distance x, because we're basically trying to figure out what is this coordinate point, where is it? Well, I went over 5 squares, but since this whole radius is 1, it's really 0.5. So I went over 0.5, which is the same thing as 1/2. And what's the other coordinate? Well, we could calculate that. We're just taking it from this right triangle though. So right here, if I have a radius of, or a hypotenuse of 1, The x distance is 1/2, and the vertical distance, or y value, is root 3 over 2. So if you convert root 3 over 2 to a decimal, it'll give you, some decimal answer, which makes a little more sense. I think it's 0.86, something like that, which is about where it looks like it lands in the y. So this is root 3 over 2. So when we talk about the unit circle values, these aren't abstract ideas. They're just coordinate points. That's all. So if it looks like you're halfway over, you're halfway over, if you're trying to figure out the x coordinate for this one. Okay, so that would be the example of a 30, 60, 90 drawn in the unit circle. So next we're going to fill in the values on this unit circle. So I never like to start with a blank unit circle like this because it's intimidating. There's a lot of, what are all these marks? And lots of stuff here. But the good thing is it's just based on the two triangles I just drew. There's really not a whole lot more than that on this unit circle. So we'll start in this coordinate, or quadrant, not coordinate. So this would be quadrant 1. This is quadrant 2. So it goes counterclockwise. This is quadrant 3. And this is quadrant 4. So when I say quadrant, I mean, 1/4 of the circle. So we'll start in this quadrant here. All we have to do is figure out some values. And so we're not going to do any math to get these exactly. We're just going to, use some reasoning. So the equation of the unit circle is 1. So if the equation of the unit circle is x squared plus y squared is 1. So the radius is 1. So that means all of the radius values are 1. So if I am at this top of the circle, this is the coordinate 0, 1. So it's up 1 unit, no units left to right. The coordinate here would be 1, 0. It's 1 unit over and no vertical movement. The other values aren't as easy. Let's fill in the degree markers though. So we start here at 0 degrees. And then if you go up to this top, the 0, 1 coordinate, this is 90 degrees. And you can kind of deduce these. So halfway between 0 and 90, you're going to have a 45. Okay, the other two are in 15-degree increments. So this is a 30-degree angle, and this is a 60-degree angle. Okay. Next, let's talk about the coordinate points. This is a 30-degree angle right here. So we're talking about this angle here is 30 degrees. And so we're going to have some values from the special right triangles. So if I go over to where these coordinate sets are, how far over and how far up did I go? Well, if I just look at this point, I'm trying to show you how to do this in a logical way. I am about halfway up the y-axis right there, where I drew that dashed line. So my y-coordinate is 1/2. Okay, and we're dealing with a 30, 60, 90 triangle, so the other coordinate is going to be root 3 over 2. So that's root 3 over 2 in the x direction, up 1/2. Okay, so let's talk about now the 60-degree angle, because that's the next easiest one. So if I just drop this line right here, I am about 0.5 over, or 1/2. So this coordinate is 1/2, and the y-coordinate is root 3 over 2. I'm going to delete some of this stuff so it's less cluttered. Okay, 45 degrees. 45 degrees is halfway between 0 and 90. So the x and the y coordinate have to be the same. And we're dealing with the 45, 45, 90. So from that special right triangle, these are just root 2 over 2 and root 2 over 2. So if you have filled out quadrant 1 of the unit circle, then you have all of the values from the rest of the circle. So I'll introduce that first. So let's just talk about that. Let's fill out all of our angles though. So you have 90, and then it's plus 30. It's 120. This is going to be plus 15, so 135. Plus 15 is 150, 180, and we just, keep going around. So 210, 225, 240, 270, 300, 315, 330, and then 360. Okay, so those are all the degrees. Next, let's talk about this quadrant 2. So since these are all just coordinate points, we know one thing. We know that the x coordinates over here are all going to be negative. So whatever they are, they're negative. And they're really just a mirror of quadrant 1. So in quadrant 1, for instance, at 30 degrees, you have root 3 over 2 and 1/2. Well, in this case, you just went negative root 3 over 2 and up 1/2. At 135, we have negative root 2 over 2, root 2 over 2. At 60, we had 1/2 root 3 over 2, so we're going to have negative 1/2 root 3 over 2. So that's it. It's just a difference of sign, and that's going to happen in every quadrant. So let's see if I can fit more of these on here. So quadrant 3 down here. If you look at these lines and we just follow those through, so I'm going to highlight this one for instance. This is going to have down here the same coordinate points as quadrant 1, but the signs are different, just like in quadrant 2. So this will still be 1/2 root 3 over 2, but we're below the y-axis, or below the x-axis, and we're to the left of the y-axis. So these are both negative. So the only thing that changes ever is the sign. At 225, we just have negative root 2 over 2, negative root 2 over 2. At 210, we're just going to have root 3 over 2, 1/2, and they're both negative. Okay, again, that's just because I'm taking these lines and just following them through. I can copy those coordinates for all of those. Okay, so last quadrant here. Let's look at, we didn't do 180. So 180 is just negative 1, 0. 270 is 0, negative 1. And in our last quadrant, these are going to be the same as the opposite quadrant. So if I let's take this one for instance. This is going to have the same coordinate, just different signs. So positive 1/2, and then we went down root 3 over 2. Root 2 over 2, negative root 2 over 2. And the last one is root 3 over 2, negative 1/2. Okay. So we have filled out most of the unit circle, and what I'll do in a second is come back and we'll look at the remaining lines on that unit circle. Okay, so I pulled up a blank unit circle and we're going to talk about radian measure. So radian measure is just, it's an equivalent measure to angles like degrees, and it's just based on, well, you've used it before. So like the circumference of a circle is 2 pi r. The radius of the unit circle is 1, so the circumference of the unit circle is 2 pi. Okay, and that translates to about 6.28. So what that tells me is that I can fit about 6.28 radiuses around this circle. Okay, so what I'm going to do right now is we're going to talk about radian measure. And first, we're going to talk about these 4 divisions I drew. So I highlighted this green X cross thing. So let's start at 0 degrees. Well, at 0 degrees, you'll also have 0 radians, so that's easy. If the whole circle has a circumference of 2 pi, half of that circle would be pi. So at 180, I would have a measure of pi. Okay, so now what do we do? So we have this section. If I go, measuring from this x-axis, I went half the distance between 0 and pi, so that's pi over 2. So if I, go back down, that would be 2 pi over 2, which is just pi, so that one's taken care of. If I go another here, it would be 3 pi over 2. So just think of it as 3 over 2 is 1.5. So it's 1.5 around the unit circle. So this is just 3 pi over 2. And if I go back to the axis, this is 4 pi over 2. So 4 pi over 2 simplifies to 2 pi. So that makes sense because that is the, there are 2 pi radians in a circle. Okay, so those 4 edges, those measures are 0, pi over 2, pi, and 3 pi over 2. Oh, and 2 pi at the end. Okay, so next we're going to look at dividing the unit circle into fourths. So I know this gets confusing. I'll probably have to go over this in live sessions, but I like breaking it up like this, even though it takes a little more time. So again, we have 0 degrees, 0 radians down there. So on the x-axis, it's just 0 degrees, 0 radians. We've already established a couple of values here. So we have established that this value at the very top is pi over 2. We've established the value to the left is just pi. The value down here is 3 pi over 2. And this is 2 pi. Okay, so we already have some of these fourths figured out. So I'm dividing pi into fourths, and since there's 2 pi in the circle, that's why we have 8 divisions. So what I'm going to do is just count. So this is my first fourth of pi. So I went 1 of the 4 divisions in the top. So this is just going to be pi over 4. If I draw another line here, we say it's pi over 2, but it's 2 pi over 4. Right here would be how many fourths did we go? We went 3 of them. So this is 3 pi over 4. And then if I draw that line down here, this is 4 pi over 4, so it's just pi. The next one is here. So how many fourths did we go? 1, 2, 3, 4, 5. So this is 5 pi over 4. So I'm just counting. And I'm counting, just adding 1 to the numerator. So then I go 1 more. So that's 6 pi over 4, which reduces to 3 pi over 2. 1 more. So how many fourths is that? It's 7. So this is 7 pi over 4. And then I go my last little fourth. So this is 8 pi over 4, which is reducing to 2 pi. So there's a lot of overlap in those. Notice we only added 4 new values. So those are the fourths. Okay, so we're going to do now the thirds and sixths together because they make more sense together because they're going to reduce. So I have the unit circle here divided into sixths. So pi is divided into 6. So that's why we have 12 divisions because we have 2 pi radians in the circle. So I'm going to do that similar thing where I'll, start right here. I'll go up. So how many sixths of the top half of the circle only did I go? Well, I went 1/6, so pi over 6. If I do that again, so I'm going to go up again. So how many sixths is that? That's 2 pi over 6. But that reduces 2 pi over 6, 2 pi over 3. Okay. If I went another sixth, I have 3 pi over 6. Well, that reduces to pi over 2. That's why we have pi over 2. And then we go 4 pi over 6 right here. So what we have here, 4 pi over 6 is a reduction again. We reduce that to 2/3 pi. So I'm just counting. So I have 4 arrows. So now I go another arrow down. And that is 5 pi over 6. And one more would be 6 pi over 6, which is pi. And so it's simply, I'm just going to count these again. So I'm going to do it again. So this would be 7 pi over 6. 8 pi over 6, which reduces to 4 pi over 3. 9 pi over 6 is going to give me a reduction to 3 pi over 2. So how many arrows did I go? 1, there's 6 in the top and then 4 down here. So this is 10 pi over 6, which, I'm sorry, this value should be right. So 7 pi over 4 here. So 10 pi over 6 reduces, divide both by 2, and you get 5 pi over 3. 11 pi over 6. And then one more would be 12 pi over 6, which is 2 pi. So those are the divisions for the sixths and thirds. Okay, so in addition to the unit circle itself and the unit circle values, we also will talk about other ways of using the unit circle. And knowing the unit circle values is necessary, and that is something we'll work on over the next several weeks a lot. So this next section, or not the next section, it's the same section, just deals with solving for values and that sort of thing. So like I said before, the unit circle, the equation is x squared plus y squared equals 1. This is just a circle centered at 0, 0, and it has a radius of 1. And so that's where the unit part of the unit circle comes from, because it's 1 unit. Okay, so example here, show that root 3 over 3, and comma root 6 over 3 is on the unit circle. So it gives us a coordinate point, and we just need to verify this is on the circle. Well, these are, it's an x and y coordinate we have, and then the equation of the unit circle is x squared plus y squared equals 1. And so if a point is on the circle, then if we plug in the point, it'll equal 1. So it's pretty simple in that way. So if I take root 3 over 3, square it, add to the y coordinate, which is root 6 over 3, and square it. Question is, does that equal 1? Well, let's square these things. So root 3 squared is just 3. 3 squared is 9. Root 6 squared is just 6. And 3 squared is 9 again. So you can see it's obviously going to be 1. It's 3/9 plus 6/9, but you do have to show that that's 9 over 9 equals 1, and 1 equals 1. So this would verify that that point is on the unit circle. Okay, so this is the same type of question, just asked in a different way. So it says p of root 2 over 2 comma y is on the unit circle, find y. So when it gives you a p like that, that's just saying it's a point. The point root 2 over 2 and whatever y is on the unit circle, find y. So again, the unit circle equation is x squared plus y squared equals 1. So this is not complicated math at all. We just plug in the x coordinate. So root 2 over 2 squared plus y squared equals 1. And we already talked through all of the unit circle values, so hopefully you might know this. You might know the y coordinate already, but so this is going to be 2 over 4 plus y squared equals 1, and we're just solving for y. So if I subtract the 2/4 from one side, that would be 1 minus 2/4, which would be 2/4, which is 1/2. So y squared equals 1/2. And you take the square root of that. You get this plus minus. And let's see here. Let me add one part to this. So find y. Oh. Yeah, say find y. And we're looking at this in quadrant 1. Okay. So at the end, I have to take the square root, and I get plus or minus root 1 over 2. So if I simplify that, that would be y equals plus or minus 1 over root 2. And we usually would rationalize this, so we're going to multiply by root 2 over 2. And y is plus or minus root 2 over 2. Okay, so that value is good, and it's in quadrant 1, so the question is the y coordinate positive or negative in quadrant 1? And it is positive, so the answer here is y equals root 2 over 2. So if you're given a point that says to find the other x or y, you just plug it into the unit circle and solve. Okay, so terminal points. Let's look at this. All of these are really small topics. There's not a lot of work involved in doing them. So this one says, given an angle measure, find a terminal point. All right, so we had already talked about how the unit circle, its circumference is 2 pi, or the angle, whatever you want to call it. So this says, given an angle measure, find a terminal point, and it gives you the angle 3 pi. So what I do with this, I'm going to put a couple of little things here. This is, the point 0 or 1, 0. And actually, I'll back up on that. All right, so next example is about terminal points. So it says, given an angle measure, find a terminal point. And once you have that filled out unit circle, you can use it as a reference, especially in the beginning, because it's going to be it'll be faster to use that at the beginning. Later on, it's faster just to remember it. But remember that I have this little red dot here on the circle. So that's at the position 1, 0. That is a radian measure of 0. And halfway across the circle, you'll have pi. Okay, so we're going to count 3 pi's. So there's 2 pi's in the unit circle. So I'm going to count them like this. I'm going to start on this axis, the x-axis, go counterclockwise and go 1 pi. Oh, I don't like it when it does that. So I'll go 1 pi, 2 pi, so that's 1 revolution around the circle, and then I'm going to add 1 more pi to this. Okay, so what's the terminal point? Well, the terminal point is really the coordinate right here. So you could see on your, fill in the unit circle, this point would be -1, 0. So the terminal point here is -1, 0. So quite simply, a terminal point is where the angle is terminated. Okay, so we'll do another one of those too. Let's do 5 pi over 4. So for this one, I'm going to make divisions in this circle. I'm going to divide pi into fourths. So pi, remember, is the top half of the unit circle. So I'll divide the top half of the circle into fourths. Okay, and I'll go ahead and do the rest of it too, just because I'm going to have to go over that. Okay, so I'm going to go to 5/4 pi. So again, I start on this axis and I just count to 5. I count 5 sections. So 1, 2, 3, 4, 5. Okay. So that angle stops right here. So the terminal point is here. On the unit circle, there's only so many values. So this is, it's a fourth. So all of the fourths are going to have the coordinate of root 2 over 2, root 2 over 2, some combination of that. So originally, our first quadrant 1 is here. It's root 2 over 2, comma, root 2 over 2. And they're both positive in that quadrant. In this quadrant down here, remember the x is negative and the y is negative, but the numbers are the same. So it's going to be root 2 over 2, but it's negative, and then negative root 2 over 2. So your terminal point here is just negative root 2 over 2, comma, root 2 over 2. And like I said, for now, you're going to basically be referencing that filled out unit circle over and over again. All right, so here's another one. I have a little diagram drawn here. This is the reference number. So the reference number is the shortest distance along the unit circle between a terminal point and the x-axis. So what it is, if we're given an angle, so in this diagram, the angle given would be t, that's in purple. Then t bar, which is in blue, that would be the reference number. So this is the reference number. Okay, the reference number is represented by t bar. Okay, so it's always the shortest distance from where that angle ends to the x-axis. So sometimes you're going to go clockwise, sometimes you go counterclockwise. So let's look at one of these, 2/3 pi. Okay, let's take a circle really quickly. Hopefully that does that yet. And then, okay, 2/3 pi. I'm going to divide pi into thirds. So there's my thirds. Okay, and let's just count that out. So I'm going to go 1/3 pi, 2/3 pi. So that is where the angle is terminated. So that would be t. T is in blue. And let's do this one in green. T bar is right here. It's the remaining distance to the axis. So this is t bar. And if you go 2/3 pi, how many thirds pi do you have to go to make 1 pi? So 2/3 pi plus pi over 3 is 3 pi over 3, which is pi. So t bar is that balance. It's just pi over 3. Because you would have to go 1/3 more to go to the x-axis. All right, so I'll do that again for 4 pi over 3. Okay, so I'll divide the top half of the circle into thirds again, and I'll just carry these through. So that's like that, something like that, doesn't have to be perfect. And then I'm going to go here and count 4/3. So I'll go 1/3, 2/3, 3/3, 4/3 is here. So that in red is t. Now the reference angle is going to be the shortest distance back to the axis. So if I do this in green again, would I go clockwise or counterclockwise? Well, I'm going to go clockwise in that case. So this would represent t bar. And how many thirds is it? It's 1/3. So t bar is pi over 3. Okay, so if you'll notice, t bar is always between 0 and 90 degrees, or 0 and pi over 2. So it'll always be an angle smaller than 90 degrees, or the equivalent radian measure of pi over 2. So let's look at one that's larger, so 22 pi over 3. Because some of these angles you'll be given, you might get like 137 pi over 5, and then you have to find the reference angle. So there's got to be a faster way than spinning around a circle and counting. And what I would do with this one is just turn it into a mixed number. So, 22 divided by 3, you'll have 7 and 1/3 left. So I'm ignoring the pi right now. So let's just, 22 divided by 3 is going to be 7, and then a remainder of 1. So we're just going to use that fraction. So the equivalent fraction here would be, it's, 22 divided by 3 is 7 and 1/3. And the pi, you'll notice I didn't even carry that over yet because pi is going to factor in right now. So this is really 7 pi plus pi over 3. So you can, if it's too confusing for you, you could just add it in that last step. The number that you get here, if it's between 0 and 90, if your remainder is between 0 and 90, that will be your reference number. So in this case, the reference number is pi over 3. So this is another way to do those problems. In fact, I'll go back to one of the other ones and show you can do it. If this number is like 5/3 pi, then you'd have to calculate the reference number for it until you get a number that is between 0 and 90 or 0 and pi over 2. So if we go back to like 4/3 pi, for instance, 4 divided by 3, let's copy it down here. 4 divided by 3 is 1 and 1/3. So it's going to be pi plus pi over 3. And if I multiply, find a common denominator here, it'll give me 4 pi over 3. But you can always do this, and that remainder, if it's between 0 and 90, 0 and pi over 2, that is your reference number. Okay, so here we have this connection between reference numbers and terminal points. So we're going to use a reference number to find a terminal point. As soon as you see a denominator, so in this case I see a thirds, a 3 in the denominator, 7/3 pi. I know that it's going to have some form of the numbers 1/2 and root 3 over 2, or root 3 over 2 and 1/2, something like that. So let's find our reference number. I'll do that again like the other one. I'll just divide these two numbers. 7 divided by 3 is going to be 2 and 1/3. If you add those together in common denominator, you'll get 7/3. And then I'm going to attach the pi. So 2 pi plus pi over 3. And so my reference number is pi over 3. Okay. And from our unit circle, if you could reference it right now, at pi over 3, the terminal point is just the coordinate point, and that's going to be 1/2 root 3 over 2. Now, right now, I know I just pulled that number out of nowhere. I'm just taking that from the unit circle. I just don't have it on my screen right now.